Okay, so our recording started. So this is just a little warm up from section 9.3. I want to make sure you're thinking correctly about these kinds of problems. Uh, we want to find the acute angle between these two lines. So take a moment to copy the example down, or the warm up down, and then we're going to go over the solution. I just want to make sure that you're all comfortable with how the solution works. Okay. Okay, I'm back. Yes, and Derek, I just saw your email, by the way. I will get if you go into Blackboard and look under course information, um, no, check, hold on. Okay, I'll get, I'll make sure you have the class key tonight. I'll make sure you get it, okay? But just for now, right now, focus on the example. Good to meet you, Derek. All right, very good, very good. Um, okay, so what we want to do is we want to find the acute angle between these two lines. Now, section 9.3 deals with dot product, and a dot product is an operation between two what? And by the way, I saw that a lot of you have been doing your homework, and I know it takes time. Multivariable calculus takes time. Okay, it just takes time. But I see you're doing your homework, and that's good. Many of you are doing your homework. So the dot product is an operation between. It's an operation on what? Good, Robin. It's an operation on vectors. That's right, Ryan. Vectors. So in this problem, we have to be able to get vectors in the problem. Okay. Well, when you see lines, what normally do you want to do with lines? What do you normally want to find that's very important for a line? Find the slope. That's right, Christopher. We want to find the slope. So we're going to do that. So let's focus on the first line. I'll call it line 1. What I'm going to do is I'm going to put that line in slope-intercept form. Okay. And then I can see that the slope is equal to -0.5. Well, remember, how's the slope defined? A slope is defined as a rise over run. Rise over run. So the fact that for every unit this line goes down, or let me rephrase it this way. For every 2 units you move on the line to the right, the line goes down 1 unit. So on the line, if you go to the right 2 units and go down 1 unit, you'll be back on the line. So pick a point on the line, go to the right 2 units, and then go down 1 unit, you'll be back on the line. This means then that the line has to be parallel to the vector 2, -1. 2 is the rise, and -1 is the run. So far, are we comfortable with that? Okay, good. And hold on here, there were a couple chat. Well, the slope is the critical thing to, yeah, we have to find the slope. But I think it is important to think about this, because hold on here, let me just hold on one moment on that. I think it's important what I said. Gosh, hold on, get a line drawn here. So here's a line, maybe there's a line, say, okay? There's a line, and on the line, this line, say, has a slope of -0.5. Okay, well, this means that if I move if I move 2 units to the right, and 1 unit down, I'm back on the line, right? So then ask yourself, what is this vector? Ah, that vector is the vector with components 2 and -1. That's our line. How many find this helpful to see, to geometrically see this? Okay, thank you, Robin. Thank you, John. And this is what I was getting at. Okay, thank you, Eric. Thank you, Naima. Very good, very good. So now, okay, we can do the same thing for the second line. The second line, we determine, has a slope of 5. So that means a rise of 5 and a run of 1. And so a vector 1, 5 is parallel to the second line. So the vector determines the orientation of the lines have slopes, but the vectors, in a sense, which the direction they point, determines the orientation of the line, because a vector has direction. Okay, are there any questions so far? All right. Okay. Well, so the lines. Okay, you know, we have 2 lines. two lines that intersect. So we know also vectors on those lines. Okay, I'm just trying to draw a nice picture here. We know, we know that's one of the vectors. Say that's the 2, -1, and the other vector is 1, 5. Obviously, this isn't drawn to scale. But given that, we can get the angle, right? So what do we have to do with these vectors A and B? What do we have to do? Well, first thing we need to do, to get the angle, we got to find the dot product. And that's what we do here on the second page. The lines meet at some angle theta that the vectors meet at. Okay. Okay, so the angle between the two lines is the same as the angle between the two vectors. Between the two vectors A and B. So we compute the dot product between A and B. And that's right. That's right. Jamal's right about the dot product. And then we have to find the magnitude of the vectors A and B. And then we make use of the fact that the dot product of A and B is equal to the magnitude of A, or the length of A, times the length of B, times the cosine of the angle between them. Okay, and so the cosine of theta will be -3 over root 130. Let me give you a moment to catch up here. Okay, give you a moment to catch up. All right. And I'm just looking at one thing here. And so theta will be the arc cosine of -3 over the square root of 130, and you get 105.3 degrees. But is that the acute angle? What does acute angle mean? Okay, well, Jamal, you're right. Acute angle means, that's right, Robin, less than 90 degrees. So now I want to go to the next page. Are we good so far? We're not there yet. We're not there yet. Okay, all right. I'll go to the next page if we're good. Thank you, Diodath. All right. So what I've drawn here is I just drew two lines, okay, to help me think about this, because, I draw two lines, and hey, interesting, between any two lines, there is going to be an acute angle between them, and there's going to be an obtuse angle between them. We just happen to find the obtuse angle, right? We just found the obtuse angle. Well, we need the acute angle, and if you add the acute angle and the obtuse angle, they have to add up to 180 degrees. I mean, look at the picture. This here is 180 degrees. And so the acute angle is 180 degrees minus 105.3 degrees, which is 74.7 degrees. And there you go. Are there any questions on that? All right, let me give you a moment to copy that. So a lot of times these problems, it's really thinking geometrically. And yes, Naima, I'll be right with you. So like when I worked this problem out, I worked it out like you know, from scratch. And oh man, I get this angle. It's not less than 90 degrees. Why is that? Well, I drew a little picture here, and then okay, now I know what to do. You know, it always helps anytime you can make a little sketch or something. It always helps in these problems. Naima, question. Naima had a question. Let's see. Naima got 17 degrees, which was right. Yeah, that's right. Your angle was already acute. That's correct. That's correct. And I guess depending on, I guess I'm trying to think here on this. Depending on what your two vectors are, you might end up with the acute angle. You might end up with the acute angle right away. So, like for instance, in the picture here, if your two vectors, okay, were this vector and this vector, you get the acute angle. You would get it. On the other, but if your two vectors were, say, let's say your two vectors were, let's say it were this vector and this vector, which is obviously what happened with me, you would get an obtuse angle. Okay, so it's sort of luck. It's sort of luck of the draw. It's sort of luck of the draw, I guess. You know, but good comment, Naima. Are there any other questions before we move on? Okay, I will stop the recording.